So, in the previous lecture, we have discussed about the dielectric, and dielectric is of two types, that is polar molecule and non-polar molecule. Also, in the last lecture, we have studied the effect of polar molecule when electric field is applied and effect of electric field on non-polar molecule also. So, what happens here? That is, when polar molecules are applied across the electric field, then that dipoles will get oriented themselves and dipole moment will get induced, because initially when no electric field is there, dipole moment is 0 for polar molecule, but when electric field will get induced, dipole moment will get introduced. But in case of non-polar, without electric field also it has a net dipole moment, and with electric field applied there is a dipole moment. But now what happens? The net intensity due to non-polar dielectric will goes on decreasing, and therefore we are getting that when non-polar molecules are get introduced or any dielectric will get introduced, the net intensity will get reduced. Net intensity will become E0 minus EP, where E0 is the original electric field intensity and EP is nothing but the intensity due to polarization. So due to this net intensity En, which is equal to E0 minus EP, due to that intensity, what happens here? The effect will be, now due to introduction of dielectric medium, net electric field will goes on decreasing. It will become En is equal to E0 minus EP. While you are knowing that potential across the capacitor is V is equal to E into D, that is the original formula. But now what is our E after dielectric? Our intensity will become net intensity. So your potential after introducing dielectric medium, the potential across capacitor will become V is equal to En multiplied by D. While your capacity formula C is equal to Q upon V. Now your V has been changed. Your V will become V is equal to En multiplied by D. So that value of V now we are going to substitute in your capacity formula. So your capacity formula will become, which is equal to Q divided by En multiplied by D. So now net electric intensity has been decreased, therefore potential will also goes on decreasing. And now if potential decreases, the capacity of a capacitor will goes on increasing. And therefore whenever dielectric is introduced, capacity will goes on increasing. And that's why in previous before two videos I have taken one numerical problem. And in that numerical problem, if air medium is there, your capacity is 26.55 into 10 raised to minus 12 farad. And when mica dielectric is introduced, whose dielectric constant is 6, then the capacity will goes on increasing. It is approximately somewhat 154 point something that we have calculated in the numerical problem. So this is nothing but the effect of dielectric on the capacity of capacitor or condenser. Now the next thing which we want to study is nothing but what is conductor. So now we are going to consider about what do you mean by conductor, what is free charges, and all that thing we are going to see now. Okay, so now in 11th standard we have seen what is conductor. Conductor is nothing but the the metal which allows the flow of electricity due to presence of free electron. So all metals which has a valence electron, which are loosely bounded towards the nuclear, and they become free, so we can say that metals start conducting when electric field is applied. So example of all conductors are nothing but all metal, human, animals, earth, all are nothing but the conductor. Now you have two more concepts. One is electrostatic shielding. It is only for 1 mark. The question can be asked. So what is electrostatic shielding? To protect any delicate instrument, that is valuable instrument, जैसे मेडिकल पर्पज़ के लिए जो वैल्यूएबल इंस्ट्रूमेंट्स यूज़ करते हैं, रिसर्च पर्पज़ के लिए जो वैल्यूएबल इंस्ट्रूमेंट यूज़ करते हैं, सो दैट इंस्ट्रूमेंट्स आर टू बी कॉल्ड एज अ डेलिकेट इंस्ट्रूमेंट. So if we want to protect that delicate instrument from the disturbing effect, then disturbing effect of other charged bodies nearby it, then that instrument has to be kept inside the hollow conductor. Why? Because inside the hollow conductor intensity is 0. So that is to be called as a electrostatic shielding. So electrostatic shielding is what? A hollow conductor where intensity is 0. That concept is to be called as a electrostatic shielding. And for this electrostatic shielding, thin metal foils are to be used. And always it is advisable, that is during lightning and thundering storm, you always has to stay inside the car than nearby a tree. Why? Because the ground will act as a conductor, your open space will act as a conductor, while the car will act as a shield. So if you are inside the car, you will get protected from the lightning. But if you are standing nearby the tree, then the open space and tree will act as a conductor and the lightning will cause very much huge damage. So this is one of the concept of the electrostatic shielding. Another concept is nothing but the Faraday's cage. Now what this Faraday's cage is, this is the enclosure which is to be used to block external electric field in a conductive material. So electromagnetic shield is the example of that. All of you are knowing this MRI machine. So in MRI, scanning rooms are always built up in such a manner that they will prevent the mixing of external radio frequency signal with the MRI machine. So that enclosure is to be called as a Faraday's cage. And so this electrostatic shielding and Faraday's cage, these are the two different concepts. So that can be asked for 1 mark. And now you will switch over to the concept as a free charges and bound charges inside the material. All of you are knowing that in metallic conductor there is a presence of electron in the outermost shell and they are loosely bounded to the nucleus. So the electrons which are loosely bounded to the nucleus can easily detach and move freely inside the metal. Now when electric field is applied, that electron can start moving in a direction opposite to the applied field, and such charges are to be called as a free charges. So what is the free charges? The charges which are present in the outermost orbit of an atom which are easily get detached from the nucleus as soon as the external electric field is applied. Now all of you are knowing that nucleus consists of positively charged ion and electrons are present in the inner shell, and that electron will always remain fixed in their orbit position. So if all of you are knowing that is how many number of electrons should remain present in the orbit, you have one formula, that is number of electron in the orbit. The formula is 2n square. Means if orbit number is 1, so number of electron revolving is 2. If orbit number is 2, then number of electrons are 8. So if that bounded electrons are fixed, like in the first orbit there are 2 electrons, so they are called bound charge. If in the second orbit there are 8 electrons, so it is called as a bound charge. But if in the third orbit there are 4 electrons, so they are called as a free charge. Why? Because actually requirement is in the third orbit the presence of electron should be 18. But there are not 18 electrons, there are only 4 electrons. So that 4 electrons are to be called as a free charge. And if there are 18 electrons, then they are called as a bound charge. So this electron inside the insulator is also the example of your bound charge. Now we can switch over to the other concept, which is nothing but the properties of conductor in the electric field. What is the first property? Net electric field inside the interior of the conductor is always 0. Suppose this is the conductor कंडक्टर में रैंडमली चार्जेस प्रेजेंट है बट दे आर अप्लाइड अक्रॉस दिस इलेक्ट्रिक फील्ड. यहाँ पे पॉजिटिव चार्ज है प्लेट पे, यहाँ पे निगेटिव चार्ज है, उसके बीच में आपका कंडक्टर है. तो क्या होगा, कंडक्टर के जितने निगेटिव चार्ज है ये कहाँ की तरफ आ जाएंगे, पॉजिटिव प्लेट की तरफ, और कंडक्टर के जितने पॉजिटिव चार्ज है वो कौन सी तरफ आ जाएंगे, निगेटिव चार्ज की तरफ. तो पॉजिटिव एंड निगेटिव चार्ज विल गेट सेपरेटेड फ्रॉम ईच अदर. सो नेट इलेक्ट्रिक फील्ड विल बिकम 0. So that's why electric field inside the conductor is 0. What is the second property? Electric field just outside the charged conductor is perpendicular to the surface of conductor. तो ये आपका कंडक्टर है. I have located this point. तो the point which is very nearer to conductor. तो at this point your direction of electric intensity is always perpendicular to the surface. This is the second property of the conductor. The third property of the conductor is net charge in the interior of the conductor is always 0. तो यहाँ पे देखो, यहाँ पे सारे पॉजिटिव चार्ज है, यहाँ पे सारे निगेटिव चार्ज है. अगर आपने पॉजिटिव चार्ज काउंट किए तो कितने, देखो 1 2 3 4 5 6 7 8 9 10, उतने ही यहाँ पे निगेटिव चार्ज है. सो 10 + 10 -, सो नेट चार्ज विल बी 0. So why it is so? Because charges are temporarily separated, therefore total charge of the system will become 0. So inside the conductor always net charge is 0. That is the third property. What is the fourth property? Charge always resides on the surface of conductor. Charge is always present on the outer surface area. It is inside the surface area, charge is 0. That is the one important thing. That is at the interior of the conductor intensity is 0. Charge inside the conductor is also 0. But once you go just outside the conductor or the surface of conductor, there is a presence of charge and therefore there is a presence of electric intensity. What is the fifth property? Electric potential is always constant for the entire conductor. So intensity inside the conductor is 0. But potential is always constant. This is also one of the important property of the conductor. Next important property is the surface charge distribution is different at the different point. Because your surface charge density formula is sigma is equal to charge upon surface area, that is S. So that's why as the surface area will goes on changing, automatically your surface charge distribution will goes on changing. So these are the 5 important property of the conductor. What is the first? Net electric field in the interior of the conductor is 0. Electric field just outside the charged conductor is always perpendicular to the surface of conductor. Third property, net charge in the interior of the conductor is always 0. Fourth property, charge always resides on the surface of conductor. Fifth property, electric potential is always constant for the entire conductor. And sixth property is the surface charge distribution may be different at a different points. So these are the 6 important properties. So these 6 important property can be asked as MCQ questions or they can be asked for the 1 mark question. So this total topic, free charge, bound charge, property of conductor, electrostatic shielding, Faraday's cage, all these topics can be asked for 1 mark or for MCQ question. So go through that concept clearly, read your textbook so you will come to know that. Okay, thank you.